Hi, and welcome to this calculation exercise. Prior to watching this video, I would suggest that you look at least the Time Value of Money 2 video and of course the first one. I do believe, however, that you might require more familiarity with the concept of time value of money, so it might be good for you to watch a few more of the videos as well as doing some exercises. You will also need to look at interest rates 1, which covers real and nominal interest rates, and I suggest that you look at some math video on logarithms so you know how to solve exponential equations. Now, please pause the video to read through this question, then proceed.
Hi, and welcome back. I'm Johan, and today we're gonna look at something very interesting. How long do I need to save 15% of my salary before I can stop working and just get the return from my savings instead to be as large as my salary? So the idea here is that we don't really know how big our salary is, so we're gonna call it X. That's not really the point. But we're going to save 15% of the salary all the time, so we're going to save 15% of it every year, and we expect to get a yearly return of 3.55% on this. Both the salary and the return are expressed in real terms, which means that our salary is going to increase by inflation, so it's constant in real terms, and also the return here is in real terms. So we want to have the same purchasing power coming from our savings as the salary is, and we want this to be constant then. So basically, you could make a timeline like this. So each year, we save 15% of whatever we earn, which is called X then. And we do this in year 1, in year 2, and so on. And we want to know how many years will it take. So how many years until the return from our savings is going to be equal to our salary. So we don't know how many years we have. That's like what we need to find here. But what we can tell is that every month we save the same amount of money. So this is clearly an annuity, right? Because we have the same cash flow and it's once per year. And when it comes to annuities, we have two formulas. One for the present value of an annuity and one for the future value of an annuity. So when is it we're actually interested in knowing this? Is it in today's terms or is it in future terms? Well, since we're saving for the future and we sometime in the future want to know when the return from our savings is equal to our salary, we're going to use the future value of a formula here. So basically, we're going to take all of these savings and we're going to move it until some point in the future. So until we'll actually end up here in year n. Okay, so when you use this formula, you will end up, you start saving 1 year from today, and you will end up in year n. If that could be 20 or 40 years in the future, we don't know that yet. Okay, so in order to do this calculation, we want the return on our savings, which we could say, for example, we can call the savings S. So the total amount we have saved can be called S at some year n. So this depends on how long into the future we are, of course. And if we take that times the return on our savings, which is 3.55%. So this is the return on our savings. We want this to be equal to our salary S. Okay, so that's the basic idea. We want the amount that we have saved up until year end times the return on those savings to equal our salary, so that we could, instead of working, we could simply live on the return from these investments. Okay, so how do we find how much we have saved then? That's a little bit tricky maybe. Well, we know how much we save every month. That's X times 0.15, so 15% of salary. So to find how much we have saved, we will save X times 0.15. That will be our C. It's the every year savings. So we're supposed to take that times 1 divided by R and the rest of the part of this formula. So we take this times 1 divided by 0.0355 times 1 plus 0.0355 according to this formula to the power of n. And we don't know this n, that's what we're seeking. And then minus 1. So this is the amount we are saving every month. Okay, so how do you get this? Well, basically, you could do it by take all of this value that we know, move it back until the present value with the normal formula, present value of an annuity, and then move it into the future again by multiplying with the future value formula. Or you can use this formula immediately, it gives the same result. Okay, so this is the amount we have saved at any particular year n. So I could test and say, okay, if I plug in 10 years, then how much money will I have as expressed in number of salary that I have? But that's not the only thing we want. We want to take this saved money times the return we get on the investment, and we want that to be equal to our salary. So now we're going to plug this whole expression here into the saved amount. So we take this expression, x times 0.15 times 1 divided by 0.0355 times 1 plus the rate 0.0355 to the power of n minus 1. Then we're supposed to multiply it by the interest rate, the return we get on the saved money, 0.0355, and we want this to be equal to our salary x. And now we need to solve this equation for n. So what you might note here is that we have x as unknown also. So it looks like we have two unknown, right? Both how big is the salary, which we find here, but also the n, the number of years that we need to save until this equation holds, and we don't know that yet. But as we can see here, this is x times something times a parenthesis times a number. So there's only multiplication on this side. What that means is that we can divide the whole side by x. And of course, we need to do the same thing on the other side. And then, since it's only multiplication up here, we can cancel the x in the very left side to the x here. And the same thing happened on the other side. They cancel out. And if you take x divided by x, you will be left by only 1. So, if we continue on the blackboard below, what we are left with is 0.15 times 1 divided by 0.0355 times 1 plus the interest rate, 0.0355 to the power of n minus 1 times the return we earn on the investment. And I said we had x divided by x on the other side, so this is equal to 1. What we have shown so far is that it doesn't matter what salary we have. It could be 10,000 per month, it could be 100,000 per month, or some other number. Irrespective of that, we still have an expression that doesn't depend on the salary. So whatever the salary is, this will be the equation we need to solve to find how long we need to save until we get the return equal to that salary. Okay, so we're going to do one more simplification. Since if you have multiplication like a times b is the same, a times b times c, you can switch places. So you could write this as c times a times b, for example. That means I'm going to take this 0.0355 here, and I'm going to move it until there. So I'm going to switch place on this parenthesis and 0.0355. And the reason I do that is will hopefully become clear soon. So we have 0.15 times 1 divided by 0.0355. Now I moved it, so this I multiply by 0.0355. And now I have divided by 0.0355 times 0.0355, so they will cancel out. And the whole thing is multiplied by this parenthesis, 1 plus 0.0355 to the power n minus 1. And it's equal to 1. So, if we now write it without these two returns, the only thing that's left is 0.15 times 1 plus 0.0355 to the power of n minus 1 is equal to 1. So it's a much smaller expression now than what we started with. And we can divide both sides by 0.15. To cancel it out from the left-hand side. And now we are left with 1 plus 0.05355 to the power of n minus 1 is equal to 1 divided by 0.15. Okay, as a final step, we're going to move this 1 over to the right-hand side, so it will be plus 1 there. And we end up with 1 plus the return to the power of n equals 1 divided by 0.15 plus 1. Okay, so now we are left with the unknown in the exponent, and we need to get it down somehow. And then we're going to use one of the laws from mathematics that tells us that if you take the logarithm, so you take ln of any number x to the power of k, the k will end up in the front times ln of x. Okay, so how will that help us? Well, we will get the exponent down, so this unknown n, we will get it in front instead, and that's what we want. So we take the logarithm of both sides, so we write ln of 1 plus the return to the power of n is equal to the logarithm of the other side, which was then 1 divided by 0.15 plus 1. Now the n will come into the front, so we move down here. We have n times ln of 1 plus 0.0355 is equal to ln of 1 divided by 0.15 plus 1. And ln is just a number like any other, or well, ln of something is just a number like any other. So we can divide by ln of 1 plus this number on both sides. And finally, we end up with an expression of the number of years that we need to save, which was n, until the return on our savings is equal to the salary that we would receive. And this expression can be written like ln of 1 divided by 0.15 plus 1 divided by ln of 1 plus 0.0355. And if we enter this into the calculator, we will get approximately 58.39. So, assuming that we need measure only whole years, it would take us 59 years until we actually have at least our own salary as a return from our investment. But what is also very interesting here is, if you see this equation as more of a formula, the 3.55% was the return we earned on the investment. So we could replace this with just the return. And 15%, that was the amount we saved every month. So maybe we could call that lambda or something, the percentage part of the salary that we save. And basically, the bigger this number would be, so the more return we can get every year, the fewer years we would take, right? Because we divide by something, if we increase the return, we divide by something bigger, so the number of years becomes smaller. And of course, if we save a bigger part of our salary, so we divide here by a larger number, it would also take fewer years before we actually have this return that we seek. And if you want, you could try this with any type of number. So choose a percentage of your salary that you save, maybe 20%, 25%, and assume an interest rate that you gain every year, And you can test this to see how much time it would take for you before you have so much saved that just the return on your savings is equal to the salary. And remember that this return that we seek, it means that you do not have to actually take any money from the savings to live the same life as what you get from your salary. Only the return on a savings alone would be equal to your salary here. Alright, that's it for today. Thank you very much.